Hello, everybody. Welcome to this presentation. My name is Jason. This is actually going to be my last research presentation I give at RITSEC as a student, seeing how it's the last week of research and I'm graduating. So please do pay attention. We have some great knowledge for you guys today. We're talking about how the four of us created the King of the Hill for ISTS. Show of hands, who participated in ISTS and did King of the Hill? Yeah. Woo. Who heard about all the wonderful things that we did? Everybody's chance should have gone up on that one. That's tough. Thanks, guys. I appreciate that. Alrighty, so we're gonna run some intros.
We're gonna agenda first.
And then after that, we're gonna talk about like what our mindset for creating, like our motivation for Koth and like what we try to do with it. Then we'll talk about some of our Koth boxes and some of our wonderful Koth box developers are gonna lead that one. And then I'm gonna talk about those guys. And I'm gonna talk about how I wrote Crazy King and how like our new scoring system works. So it'll be a very, very nice presentation in my wonderful opinion. So this is me. This is nice pictures of me that I pulled out of the camera roll today. I'm a big red team guy. I'm a big idea guy as well. A long time ago, Mav and I sat down to talk about running a Koth competition. Like, who knows Mav, by the way? All right, cool. I still got the majority on that one. That's good. Sometimes I talk about people, and then nobody knows who I'm talking about, and then I get sad. Like, if I said, like Dan Sad's friend, and we know who I'm talking about? Yeah, I got one. I got Brad. That's good. Anyways, also, besides red teaming, going to the gym, I also freebird on the weekends. And then,
All right, hello. Yeah, I'm Joe. This is also my final research presentation. I'm also graduating. We're out of here. From the great place of Long Island. A lot of security engineering, mostly red team, but really just writing code for general security. Rust Station, live, love, Rust, run Rust. I do e-board, I do sysadmin, I do ham radio. If you see me out in like Greek lawn with a 5-meter tall antenna in the sky, come talk to me. I'm probably talking to like Spain.
All right, yeah. Hit the next. This is me, one half of the successors to Koth, also from Long Island. God bless. Second in a something year, doing cool stuff. I rock climb and volleyball occasionally, and a future MITRE intern. Wow. This is big. This is very big.
Hello, I'm Lukas. I'm your second half of the successor for Koth. I'm a second year. I'm deaf with the cochlear implants. I'm also from Ohio. And I also like to play volleyball. So, thank you.
Yeah, so I can start with this first. Mm-hmm. So coming into King of the Hill, we wanted to make sure we hit a couple of key points. We wanted to make sure we had fun and interesting exploits that you aren't just doing something like boring and takes like 1 second, but you also wanted stuff. Yeah, you wanted stuff that wouldn't be too difficult, stuff that wouldn't be like too easy either. So there's like a tough balance that you have to make. This is seen with like making a CTF challenge, like gauging the difficulty. It's kind of a similar idea when making a King of the Hill box. Along with it not being too difficult, you also want multiple ways onto a box. This is not going to be like our success story for Koth, because this is definitely one of the things that we didn't do so well. But that's where me and Lukas come out next year. And you're also going to want a variety of common and some uncommon vulnerabilities. You're going to see we have like Eternal Blue, and then we also have some custom stuff that we made. So, stuff that should be easy, stuff that should be not, stuff that's in Metasploit that you can easily just run, and stuff that isn't. So, and something that, and also not making your challenges a time sink, because within ISTS, you got 5 people on a team. You got so much people to do Koth. You're going to have people doing CTF. You're going to be having people doing the blue-red team. You're going to have people like really spread thin with their time commitments. So having a Koth box that is fun and interesting and complex is cool, but you want to make it reasonable within the time frame because they only have access to Koth during the competition. It's unlike the CTF when they have all the time in the world to look at that during when they're home from not competing. But.
Quick question. Does everybody know what we mean by when we say King of the Hill? Anybody not understand that? All right, great. There you go, Lucas.
Okay, so King of the Hill is like a competition where you have like amount of boxes where they are vulnerable, and each team can work together to claim that box. And Jason will talk about this later. These boxes will be scored by a Crazy King, and once you claim these boxes, you'll eventually accumulate scores and points. It says all of these boxes have like a vulnerabilities. You can research these vulnerabilities, use them to exploit, get into the box, and then take that box and hold it onto it. You can lock it down and all of those fun stuff.
Yeah, it's more of like the attack and defend kind of mindset. So you first attack the box that has a vulnerable service on it. Then once you get on, you want to lock it down and prevent other people from getting access. And for the general overview, you can take it.
So in the competition as well, we had two networks. First, we had an easy network, which was external, and we also had a hard network, which was internal. And the way this works is that once you get into a easy box that is in the easy network, you would have be able to access the box that is in the hard network. So it's getting closer to like the top of the hill situation. It's just something unique that was different from the other King of the Hill competitions, which made this really fun in general.
All right, I'm gonna talk about some of the COTS boxes I made. The first ones I made are what I call exploit DB vulnerabilities, because I looked on exploit DB, grabbed the source code, and put it on a box. These are good because for those who are very new to like attacking boxes, finding vulnerabilities, if you open the service, like looked up the version, you would get some type of resource on how to solve it. So some of the main ones I did were ProFTPD 133C, which is a backdoored version. Eternal Blue, for those who don't know, is a Windows 0 day from like 2012, where you can exploit SMB to get NT Authority system access. Shell Shock, which is a bash vulnerability that is present in some Apache versions, if you have the right modules installed. Those are just some of the cool ones that, if you've been like Nmap, Script Vuln, there's a lot of vulnerability scanners, they pick up those pretty easily. So you can at least get one of the boxes in your favor. The next one I did was a Windows web server. I learned I don't want to make Windows web servers anymore. What I did is I used XAMPP, which is kind of like the LAMP stack in Linux, if you've ever done it. It's Apache, MySQL, and PHP. So what you do, so that was running in the background, and I had an exposed SMB share. So people could log in, change the PHP files, and then give themselves a shell through PHP. So that was the goal on that one. A couple people did it. That was fun. My favorite one on the easy side was Minecraft. I really wanted to do a Log4j challenge. I didn't know how to do it because I didn't want to force people to log into their Minecraft accounts. Because one, people playing Minecraft in the infrastructure would probably like slow things down. And also people don't want to put their credentials in a COTS machine for valid reason. So what I ended up doing is in the website, I exposed the Allcon CLI, which is the remote console utility that Minecraft provides. I exposed the credentials in there so people can log in, and then use the console commands to trigger Log4j to eventually get a shell. And I also had 3 hard ones that I made. I love Kubernetes. For those who don't know, Kubernetes is the best thing known to man. So what I did is I made a website in Kubernetes using MicroK8s, which is a Ubuntu one-box kube cluster. And then once you found the admin creds, you could break out of the pod, get root access onto the machine. CI/CD runners, this is something you can see sometimes in production. So a lot of common Git platforms, so like your GitLab, Git will have CI/CD runners, which are just little agents that run on your box. They commonly use Docker, so instead of running on your host system, it's running in a container. But if you convince it enough, you can run it on the host level. So if someone went onto Git, made a little CI/CD runner script that just made a reverse shell, you'd have a shell as a user in the host machine. Finally, blind SQL. This one was kind of fun. It was blind SQL, which then people kept getting confused because they thought like, oh, I have blind SQL, I see credentials in the database, that must be SSH into the machine. it wasn't. You had to then use that in a PHP MyAdmin that was attached to the website, which you could see in like the comments, or if you just ran Dirtbuster against it. And that PHP MyAdmin was then vulnerable to RCE. You always got to think outside the box because you never know. People are going to expect things to be like straightforward, but you need to make people think so that way they are able to actually learn something out of this competition. Because at the end goal of most competitions is that the competitors learn something in the end.
Yeah, so now I'm going to talk a little more in depth about the challenge I made. So raise your hand if you've ever done a SQL injection attack before. Okay, I would hope it's a couple of you. So going through the general methodology of how you would attack this box. And I'm going to go through how I created and thought of it in the first place. So this is a custom SQL injection box that I made. So you casually do your little end map of the network, and you'll see a bunch of IP addresses, a bunch of open ports. And once you find that open port, 1738 on this box, you can try to netcat it. And then you get presented with this trading service app. So on theme with the competition, it was like cowboy themed. So I kind of modeled this after a trading post where you get to look up people's crypto wallet addresses. ChatGPT, thank you for those. And it mentions here, still working on my cron implementation. And then the example didn't used to work, I fixed it. So if you provided that example, you'll be able to pull the balance, the transactions, and your swag level. Just arbitrary things that I made up. So then with that, you notice cron, and you have your queries. So this is what I pulled from the server code. It's just a Python server running, and this is where it'll execute your select star from the crypto users, where your wallet address is your user input, and then end with a quote and a semicolon. So that's the kind of idea of this is where your payload's going to end up going. So you have a vulnerable SQL query that you just have to simply escape, and then you can execute arbitrary SQL. But how can you actually exploit this? So does anyone have any ideas on how you would tie something you can do with SQL and something you can do with cron running on that container? It's okay if you don't. A lot of people during the competition didn't. Yeah, so going into it, let's take a look at what the payload consists of. So you go through your quote union select, which allows you to append another query. And then in here, we know cron is running. So what if it was possible to put a file in one of the etc cron directories, which it'll run your file? So that's where the idea of an awk reverse shell. Awk is pretty integral to a lot of Docker containers, so it's by default on it. And the command into out file is where you actually take whatever constants that you want to send, and then you output it to a file on disk. And then you would just have that cron job run it. And then also when you do query one of the crypto addresses, you notice that there are 4 different values. This is just important for how you format the payload. And also knowing your cron tab format is also pretty important. If you just want your cron tab going every minute, you just do 5 stars. So what the actual payload looks like is, single quote, union select. So now you're running your own stuff. So single quote, and then this is the actual contents of the cron file. So you have your 5 stars that you want your reverse shell coming back to you every minute. You specify the user root, and then you just provide your whatever payload. It doesn't have to be awk, but reverseshells.com auto-generates this, and it's pretty simple. You have it calling back to your IP on whatever port you want to listen to. It does its print shell, etc. Piping whatever errors to dev null, and then making sure that in this single quote is the first, you're providing the wallet address. So you had to provide these other 3 just empty quote strings to fill in the balance, num transactions, and swag level that you would have been provided if you ran it against the query. And then with that, you can put that into out file, which will then write to the directory. I had to make this directory writable, for this to actually work, because usually your cron wouldn't really be able to do this, or your SQL user wouldn't really be able to do this. So in etsy, cron.d, let's go.txt, you can make it whatever, and then having a hash tag at the end, which will comment out the rest of the line. So generally when you're looking at where should I put this cron file? If you get that far to know cron implementation, something with a cron job, you got to figure out where on a system would cron jobs be run from. So there's a lot of other possibilities. I mean, you can pretty much put files all over the system if you really wanted to. So even if you just tried, I know var spool and then your user cron, this is your root level crons and etsy cron.d. This is your system-wide cron jobs. So aiming there. There was a lot of issues with having the cron daemon in Docker work. This was a box that me and Lukas split once I gave up halfway through, and then he cleaned it up at the end.
Yeah, I would like to shout out to Michael Scouse for helping out with this. He was able to guide me through the right directions, and I was able to figure out the end. Along with the script, the cron job, I also had to make several changes to the box where I have a job to add a new line to the new cron jobs so they can execute, because without it, it wouldn't execute at all. So that's why I had to.
Yeah, for some reason, cron job files need to have a new line character at the end. So yeah, making sure that it has that at the end. There also was a big trade-off for having this running in a Docker container. Is that Docker comes, it's built, it's going to work no matter what usually, but cron comes, or Docker comes very bare bones with your container usually, and it kind of removes all the necessary functions for something like cron to work, which is then the kind of trade-off you kind of have to see with running it on bare metal or running it in a Docker container like this. So, but that's the challenge. I thought it was a pretty cool idea, but yeah, and some people did actually solve it. So.
And then now for my box, I used a WordPress website. There was a vulnerable theme that the website had. It was called One Tone theme. Only in versions 3.0.0 to 3.0.6, it had a vulnerable import thing setting where you can import anything through the link. It says !action equal one tone options import. If you can manipulate that URL and then import anything. So the idea was host a script on your machine. In this script, you would be creating a new user. To create a user, and and then once you have that hosted on your machine, you can curl the website and have the the script as a data payload. So once that is imported successfully, you'll see it's imported into top bar info content. So on the next slide, you can see the script hides in the top bar, like the front page header. So you can't see, the user can't see this. The admin can only see this if they go into customize. So this is what's hiding at the front page header. So what we need is a like a login admin to log via the front page just once. That's all. And then the script calls to the the script that is hosted on your machine. It will execute it. So once that the script is executed, you get an administrator user. It was that simple, and it's kind of dumb that the author did not patch. The author did not bother to patch this at all. It's really dumb.
Yeah, so thank you guys. That was a good chunk of the boxes that were put on the Koth network for this ISTS. There are some other ones that we didn't cover, but you might see them in Quora if you do that this weekend. So We're talking a little bit about how Crazy King itself worked. So Crazy King is a novel King of the Hill scoring system. The cool features of it is an uptime monitoring system for each of the hills. Then we have a hill ownership system so that teams can claim a hill and then another team can come and try to claim it later. As part of that, we also had like a cooldown period where if two teams try to claim the hill at the same time, there would be an exponential back off where both teams could not claim the hill. And, instead of trying to claim it, they would have to focus on kicking the other team out. Then we also had an admin endpoint, a couple of admin endpoints for Crazy King, just for hill administration and configuration. And the whole thing was Dockerized. There was it was mostly written in as a Flask app. There was also a backend database in MySQL. Then we did HTTPS via Caddy. So that's a pretty common Docker stack, I'd say, these days, using Flask, MySQL, and then Caddy. Caddy is a great thing, even if you're not using Python. Anyways, the total project was about 2,200 lines of Python, plus some, I don't know, kind of like another 100 in different config files and Docker files and stuff like that. But the overall, like, the reason why we wrote Crazy King is because not like a basic uptime monitoring system like ScoreStack or scoring engine or CompScore, they can't handle, or they're not configured to handle a box that's going to change ownership. When you have like your regular competition, each team owns those boxes for owns their LAN and their cloud for the entire competition. And if the check is up on that box, that team is going to get the points. For King of the Hill, ownership can change, and you have to be able. The scoring system needs to be able to work with those changes and assign points dynamically to the team that owns the box. So, trying to create a system that can handle ownership claims and stuff like that was the driving motivation behind creating Crazy King. This idea started about a year and a half ago, I think, when me and Michael Vaughn sat down to kind of create a Koth competition and try to figure out how we could make it better. And creating a scoring system was the first step of that. And so we made a spec sheet, and I'm proud to say that the ideas that we had back then is pretty much what I wrote for Crazy King, to the T. So it's cool that our initial idea didn't have to go through a lot of modifications to make it work. This right here is the only front end that the team saw. This is like pretty much everything done with Crazy King was just API endpoints, mostly because I'm not a front end web developer and I didn't really want to learn. So this is just a little bit HTML, a little bit of CSS, and like a Jinja template, and it works works wonderfully. So what the teams could see was the name of the host, who owned it, and then if the check was up or not. At the end of the competition which is when we took the screenshot. Every single box was owned, which was really cool for us to see. Cause people did the Koth, which has been something that hasn't always happened. So that was cool to see from the competition. So there was a couple components to Crazy King. There was the Flask app, which had the user endpoints and admin endpoints. Then there was the backend database. Then I wrote a thing called Jester, which is an uptime monitor that did the service checks for we had a lot of HTTP checks, a lot of SMB checks, FTP, and like some other offshoot like socket and other miscellaneous checks. Then I wrote a lot of tests, and then I wrote some clients that would that would get dropped on the hills. The way the users would interact with everything is they would pop the box by gaining RCE on the box. From there, they could execute the client binary. Then if they would put in their 32-bit team identifier, then they would try to claim the hill. The claim would go to Crazy King. The Crazy King would run some checks to see if the claim was valid or not, and return if it was successful or if it failed back to the hill. So this structure was actually very critical to making sure that teams weren't trying to claim hills if they weren't on that hill. So one of the checks that we did was like a little remote IP check, make sure that the request for claimant actually came from Koth boxes instead of some fraudulent IP somewhere else. So yeah. The claims were successful if the team didn't own the box already, if the box hadn't been claimed within the last 2 minutes, i.e. there weren't two teams fighting for it at the same time, and the team hadn't tried to claim the box within the last 5 minutes. So if any of these checks weren't met, then the team would be given a rate limit. It would be given like a back off timer, like don't try to claim for the next 5 minutes. And then if they did and they if they tried to claim again while their back off timer was still active, it became exponentially longer. Once it exceeded an hour, the team was banned from that box. And that was just our way of making sure that people were not trying to like DDoS their infrastructure or cheat their way through stuff. So, and then the scoring process, the team would get points if they own the hill and the check on the box was and the check was up on the box. There's no point in having something if the service is not actually running. So we were going to do demo time, then I realized that the code base that I was going to show isn't on this laptop, so no demo time. Any questions? Yes. No. Crazy King V1 will be published at some point over the summer once I have time to document everything and make it nice and pretty. Other questions? Alrighty. Thanks, guys.
Boom. Get off of the stand.